Assalamualaikum and hi. So welcome back to the video. Our last subtopic for week number 4 we call as a point of inflection. Okay, for by definition, point of inflection is where the graph changes in concavity. Remember just now we have two type of concavity. Whether you have concave down like an umbrella or concave up like a bowl, right? Okay, and one more thing, if you notice, okay, in the previous exercise or the previous example, I sketch or I highlight the line of concave up and in between concave and concave down. I sketch only half of it. Okay, kenapa I tak sketch along the curve here for the concave down? Sorry, concave up. But what I do is I just put as half of it. This green color, green highlight. Because in between concave up and concave down, there is a point of inflection. Kalau kita tengok balik the definition of point of inflection. Point of inflection is where the graph change in concavity. Okay, so kalau kita tengok, I tak lorikkan the whole thing. But what I do is I put half of it. Okay, sampai dekat tengah ni, the connection between concave up and concave down, there is a point of inflection. Okay, actually the gradient steepness start changes, and they start change the steepness from more negative become less, from more negative, because this is a negative gradient, from more negative to less negative. Okay, so in between of the concave up, concave down, there is a point of inflection. Okay, change in concavity. Right, so at the point of inflection, the graph reach a local maximum or local minimum in steepness. Okay, you tengok for this line, okay, if you notice, okay, this line have a they start climbing up, right? Climbing up, meaning you have a positive gradient throughout the line. But you can see from here, this is more positive gradient, but towards at a point in the middle, the positive gradient become lesser. Sebab tu kat sini less step than nearby point. Point apa? Point E. Okay, actually point of inflection ni dia ada dua type. Point of inflection consists of two type. Okay, type number 1, dia include stationary point dekat sini, dekat E ni. Okay, you have to read the slide, ada email, because the explanation is more detailed. Okay, but I just want to highlight the point of inflection basically is connection between of two concavity, and then the reach a local maximum or minimum in the steepness lah. They become less steep, meaning in between from more steep to less steep ada point of inflection. Sama juga di sini, ini clearly lah, consists of connection between concave up and concave down. Okay, so tengok sini, they start climbing up, tapi when they reach at point of inflection, they dah start slowing down. Okay, sebab kat atas ni ada satu lagi stationary point. Okay, otherwise kalau they keep maintain the gradient over here, they will never stop at this point of they will never stop at this stationary point. Okay, sebab dia nak stop, sebab kat sini f prime x is equal to 0. F prime x equal to 0, meaning kat sini dia kena stop sekejap, like ada transition, sebab stationary point ni equal to returning point kan, from positive gradient become negative. So kalau dia keep on increase the gradient, they will never stop at this stationary point. Dia tak ada transition, dia akan terus climbing up. Okay, so therefore it's important untuk tukarkan kelajuan lah. So actually point of inflection ni dia punya analogy like a switch yang tukar the steepness of the gradient. Okay, alright. So how to identify or how to determine the point of inflection? So kita gunakan second derivative test. Okay, so make sure your point of inflection give us 0 by using the second derivative test. Okay, right. So let's take a look the example from delta. Okay, so the question, determine the coordinate of the point of inflection in each of the cubic curve below. So kita tahu yang point of inflection for the second derivative test, they will give us 0. So for this question, you have to differentiate 2 times. So 3x squared minus 18x plus 8. Differentiate for the second time, you will have 6x minus 18. So at y double prime equal to 0, so 0 equal to 6x minus 18. So what do we have? X equal to 3. So since they asked for the coordinate, so you have to find the y value. So therefore substitute x equal to 3 into y. So y equal to 3, 3 cube minus 9, 3 squared, 8 times 3 plus 10. So therefore y over here you akan dapat negative 20. So the coordinate will be 3 and negative 20. This is the coordinate of the point of inflection. Right? Okay. Another question. Consider a function fx equal to x plus 2 x over 2 plus sine x, where x greater than 0. A. Determine the coordinates of the first turning point. First turning point and state its nature. So for the first question, for the turning point, remember f prime x equal to 0. Nature could be 2 lah. Whether you have a minimum where your f double prime of x greater than 0, or maximum f double prime x less than 0. Kita gunakan second derivative test in order to check or in order to identify the nature of the turning point. Alright. Okay. So we have fx equal to x over 2 plus sine x. First derivative, differentiate, you akan dapat 1 over 2 plus cos x. Second derivative, you will have differentiate 1 over 2 is 0, differentiate cos is negative sine of x. Okay, now since they asked to determine the coordinate of the turning point, so kita gunakan f prime x equal to 0. Therefore 0 equal to 1 over 2 plus cos x. So negative 1 over 2 equal to cos x. So by using the cos inverse, so x equal to cos inverse of negative 1 over 2. This time use mode radian. Okay, because this is a number. Change your calculator mode to radian in order to get your x. So if you press your calculator, you will have over here 2/3 pi. Kalau you're not interested using the pi, you boleh gunakan decimal, which is 2.09. Tapi calculator should be in the radian mode. Tak boleh tukar Okay. Okay, now you have your x, but the question asks to find the coordinate. So substitute x equal to 2 pi over 3 into fx. So substitute f 2 pi over 3. You press your calculator, you akan dapat sini ialah pi over 3 plus square root of 3 over 2, or is equal to 1.913. Okay, so therefore the coordinate would be 2 pi over 3 or pi over 3 plus square root of 3 over 2, or you may leave your answer with the decimal number. Doesn't really matter, both are correct. 2.09, 1.193. Okay, now how about the nature? So just now the nature So kita tahu tadi f double prime of x kita dapat tadi ialah negative cos. Okay. Oh, sorry, my bad. The f double prime is negative sin x. So substitute x equal to 2 pi over 3 into f double prime. Okay, sebab nature, we have to, in order to determine the nature, we have to use the second derivative test. So substitute x equal to 2 pi over 3 into f double prime. Jangan substitute dalam f, because f ni kita dah dapat previously the coordinate of the turning point, but substitute to the f double prime. So therefore kita boleh dapat dia whether you have a positive or negative. So f 2 pi over 3 equal to negative sin 2 pi over 3. So over here again, use your calculator in the mode of radian, and because we are using pi over here, so if you press your calculator, you have negative square root of 3 over 2. Since this is a negative number which is less than 0, so the nature will be maximum. Okay, alright. So what is the conclusion that you can make? Okay, so number one, in order to determine whether you have increasing or decreasing or stationary point, use first derivative test. In order to determine the nature of your stationary point, I repeat, in order to determine the nature of the stationary point, you have to use the second derivative test. Okay, and one more thing, point of inflection also use the second derivative test. Okay, you just follow my orange table in the slide, and they will help you a lot in order to understand the week number 4 chapter. Alright, So if you have any question, just let me know. So see you soon in the next video.